Hi engineers. In this lecture we are going to discuss about soft and hard magnetic material. So depending on the size of hysteresis, BH curves or IH curve, ferromagnetic materials are classified into two types mainly, soft and hard magnetic material. So if the area of the hysteresis loop is very small, that is what we call soft magnetic material, and whenever this area of the magnetic field is very high, then we will say it is hard magnetic material, right? So what is remnant field and coercive field, all those things we studied in hysteresis curve. Just refer that video if you require more information on the part how these loops are formed. Here we classify the materials based on hysteresis loop area as a hard magnetic materials and soft order magnetic materials. So when come to the properties and applications, these materials, hard magnetic materials, demagnetization are known as it is very hard to demagnetize. Losses are very high. Hard magnetic material, high coercivity, low initial permeability, high hysteresis energy loss, high remnant polarization. So this is the high coercive field, high remnant field, and high saturation flux density, low susceptibility, low eddy current loss. All these are the properties of this hard magnetic material. Examples of alloys of aluminum, nickel, cobalt, copper, and iron, tungsten steel alloy, chromium steel alloy, etc. Where we will use these hard magnetic material? Basically in small motors, in hand tool, Walkman equipment, CD motors, MRI, magnetic resonance imaging, body scanners, computer applications. Those places we will use this hard magnetic material. The next one is soft magnetic material, ferromagnetic materials in which are easily magnetized and demagnetized. So when come to the hard magnetic materials, it is difficult to magnetize as well as demagnetize. But when come to soft magnetic materials, it is very easy to magnetize as well as demagnetize. It has low coercivity, low hysteresis loss, high permeability, then high susceptibility, low remnant magnetization. When come to the examples, alloys of iron, nickel, silicon, commercial iron, alloys of nickel, copper, chromium, iron, all these materials has this soft magnetic nature, where we can use core of the transformers, power generators, audio frequency applications, right? Like this, in different applications we use this soft magnetic material. When come to the differences in the exam, sometimes they will ask compare between soft and hard magnetic material. Whenever we are writing these parameters, always include the diagram. That is a good idea. Soft magnetic materials can be easily magnetized, demagnetized, it is a hard. Then small magnetic field magnetizes a soft magnetic material. Since domain walls move easily and reverse, it is hard to magnetize. It consists of very steep hysteresis loop, broad hysteresis. Its hysteresis area is small, loss is low, but this area is high, so loss will be very high. They have large value of susceptibility and permeability. When come to this one, it's a low value. The coercive and retentivity values are small. For this hard magnet, it is a large. When soft magnetic materials are used in preparation of magnetic core materials used in transformer, electric motor, magnetic amplifier, this is used in loudspeakers, microphone, magnetic detectors, etc. Thank you for watching this video.